And another ABS versus ASA battle, both reinforced with glass fibers and both from the Siraya. And they are both printed on same temperatures, and probably this is one of the reasons why one of them will be stronger. Try to guess which one. Welcome to another filament testing video. Siraya Tech sent me some filaments for the testing. Yes, that's Siraya Tech who created those great resin materials which I already presented on this channel. Now they have the filaments too. And I got these boxes for free, but I'm not paid anything about this, so this is not a sponsored video. And these two are flexible materials, 95 and 85 on Shear scale. Even the 95 is quite flexible material, but 85A is extremely soft, and they will be tested in a separate video. These two are PET-CF and PAHT-CF or PPA-CF. Now on the website I can see that they have some core version 2 of this, and I wrote an email today to them if they want that to be included in this video. Anyway, so these 2 or 3 filaments will be tested in a separate video. And for this video I have ABS and ASA, both reinforced with glass fibers, and both are in white color. The price is slightly different. ABS is $35 and ASA is $40. Of course, depend on the country. And in both cases, according to their website, they have superior toughness and great dimensional stability thanks to these fibers. And this is correct for most of the fiber reinforced filaments. Now the ASA has the advantage that it is UV resistant, and overall it is good for outdoor use. It is more weather resistant material, but as I mentioned, it is a little bit more expensive. Now, even if they are easier for the printing compared to the non-reinforced versions, it is recommended to use the enclosed printer, and because of those glass fiber, we have to use the hardened steel nozzle or something similar. And I will do all those printings on my Benchy X1 carbon. The packaging is nice in this alufoil, which is better against the moisture, but I can see that this is not vacuum packaging or the air leaked in, and don't forget these bags are resealable on this side. And in both cases I can see the same recommended print temperatures on this sticker. The print temperature between 250 and 270 degrees Celsius, the bed between 100 and 110 degrees Celsius, fan on but between 0 and 50%, and keep the filament dry. Don't forget to cut it above the sealing line. Nice carbon spool, but I couldn't see the desiccant inside the packaging. The edge is protected, theoretically it could go into the AMS unit, but this filament is too brittle, so don't place it inside the AMS. Information about the 3D printing on the sticker, and really nice to see this scale. Approximately we can see how much filament we have on it, and end of the filament is locked into these holes, but this is very brittle filament. Let's see the ASA. And I can see the end of the filament is even broken inside those holes, because this is very brittle filament. Usually in this case, the end of the filament is glued to the spool, so it will not break inside those holes. And I think this spool is a little bit too small for this material. Density of the ABS or ASA is smaller. This means for 1 kilogram spool we need more material, and it covers the holes for the locking end of the filament, which we shouldn't use anyway. Keep it dry, very important information on the spool. So both material goes into the filament dryer, and since they may have a bad smell, I'm using X1 carbon, which is connected to this wall, the exhaust fan, and I will use the engineering plate with the glue on it. On Siraya Tech website we can find profiles for cellular printers, including X1 carbon, which I will use, and the different settings for both materials, 270 on the nozzle and 16 the maximal flow. I'm starting with ABS printing. This is the inspection of the first layer by the Benchy X1 carbon, and here you can see the printing perfectly straight objects, so absolutely no problems here. And at the end of the printing I'm enabling the exhaust fan, so it will suck out that smell of the ABS. The adhesion is great. With flexing I can remove it. And of course I need a Benchy to analyze better the print quality. And then moving to the ASA. Also I have the prepared profiles, very similar G-code I'm using here too. And here you can see the printing. Quite fast printing actually, it was finished in 45 minutes. Last few objects vertically printed for the layer adhesion or similar tests. And after the exhaust fan I can remove the objects. And of course I need the Benchy from the ASA too. And just in case, the ASA parts I mark with this red dot. It is hard to present them in the camera in white color, but these two benches are nearly perfect. I mean, those layer lines are quite hidden thanks to these fibers. The hull line is still visible very minimally, but beside that, no any other errors on this benchy. Just quickly the shrinking test. This is the ABS part, and the design length is 80 millimeters here. And this is the ASA. It is better than non-reinforced versions, but I was expecting less shrinking here. Tensile test, I'm starting with horizontally printed test objects. And this is the average value. And now the ASA. The layer adhesion with vertical printed test objects. Good number. ASA. Well, still acceptable. As most of you requested, analyzing the results immediately after the testing. On the tensile test, no big difference between these two materials, and they are very close to the average ABS and ASA tensile strength. On the layer adhesion test, well, the ASA is noticeably weaker, on the edge of acceptable, but probably we can play with this a little bit more because the printability is good and they can be properly printed on higher temperatures too, and usually the ASA requires higher print temperature, but in this case it was the same. Two-sided Shear test, and I'm starting with horizontally printed test objects, side by side two materials. And these are printed in vertical position where the layer adhesion is important. With horizontally printed test objects, no big difference, but in both cases very strong materials, so these fibers helps in this test. With vertically printed test objects, well, we can see that weakness of the layer adhesion with the ASA part, but this is also acceptable. Torque or twist test with horizontally and vertically printed test objects, and I'm starting with the ABS. Torque or twist test, and I'm starting with horizontally printed test objects. 1.0.8. And these are vertically printed where the layer adhesion is important. 0.8. 1.3. Well, it can be stronger a little bit in this test, but partly this was a result of the weaker layer adhesion. On torque or twist test, this is the load at 90-degree rotation with the horizontally printed test object, and here the ABS was noticeably stronger compared to the ASA, and similar ratio we have with the vertically printed test objects where the layer adhesion is important, but it is interesting to notice that the numbers are similar with the horizontally and vertically printed test objects because they have the same dimensions. 3-point bending test, and these are the loads which I will place one by one, and I will measure the deformation after 1, 30 and 60 seconds. Distance between supports is 50 millimeters, and currently this is the deformation under 5 kilograms, and this is under 10 kilograms, and a very slow deformation during the time. And after this, just a slightly more deformation on the ASA part. On 3-point bending test, this is the deformation under these loads after 30 seconds. No big difference between these two materials, but let's analyze better this graph where we can see the deformation under these loads after 1, 30 and 60 seconds. And actually we can see that no big difference between these two materials, and they can handle quite good even this bigger load because there is no additional deformation during the time or very minimally. Temperature test in the oven. Usually regular ABS or ASA starts to deform at 90 degrees Celsius, but here it was a little bit higher, they start to deform at 101 degrees Celsius. And the third object is the PET-CF by Siraya. Impact test, this is Siraya ABS glass fiber. 0 position. ASA glass fiber. Similar breaks, but let's check the numbers. 0 position of the hammer, and this is after breaking the ABS part, and this after ASA. And this means that the ABS is slightly tougher material compared to the ASA. On the impact test, no big difference, the ABS is slightly tougher compared to the ASA, but in both cases they are more brittle materials compared to the non-reinforced average ABS or ASA part. The creep test, the deformation under the constant load of 1.25 kilograms, and I will measure the distance between two reference surfaces in next 5 days. ABS 14.29, ASA 14.39. This is the last 5th day of the testing, let's measure them. $14.52, 14.94, Interestingly, last 4 days I have very similar creeping of only 1 or 2 hundredths of millimeters. And now let's remove the loads. After this test, almost no permanent deformation on them, but I can see slightly more deformation on the ASA part compared to the ABS. On creep test, this is the distance between two reference surfaces, and the smaller values are better, but this is only the bending. What we need is the difference between 2 days, that's the creeping. And here we can see that the ABS is slightly better compared to the ASA, less creeping, but in both cases these are quite good materials. I mean, only some minimal creeping on day 1, but after this the deformation was very minimal. All results one more time without comments, and these 2 lines will be added to that summary table for my Patreon supporters, so they can very easily compare these results to any of those which I did in earlier videos. Usually when I test the ABS and ASA from the same manufacturer, the mechanical properties are usually very similar. But in this case I can see slightly advantage on the ABS side. Maybe the ASA requires a little bit bigger temperature because in this case they are printed on the same temperature. And the other advantage I can see on the ASA side is that UV and weather resistance. Now, in the meantime, maybe you saw in the video that I started the testing with the Siraya PET-CF filament, and so far very promising material. And just for example, this is a temperature test, and I take out this test object on 210 degrees Celsius, and I had to stop here the experiment. So very promising material. Don't forget to subscribe because you may skip that video very easily. I need some time for few testings, and video editing maybe next Friday will be finish the video. In the meantime, as a result of the YouTube poll, we discussed with Siraya, all 3 premium nylon filaments will be tested in one video, the regular, carbon fiber and the core version. Until that, thank you for watching and happy printing.